Swayam Prabha. Digital India. Educated India.
Namaste. In today's tutorial we are going to discuss about how to calculate the safety of a non-structural element. So if we see the three element which can give a failure of a non-structural element is first is sliding, another one is a rocking, and third one is a toppling. Now how exactly it happens? So suppose this is my non-structural element, say almirah. Now for in first case sliding it will go like this. So if this is happening, we will tell it as a identify it as a sliding. Second is rocking behavior. So this is the rocking behavior where object will not slide but it will rock at one of the side. And third one is in case of excessive rocking, this will topple. So these are the three failure. We will check the safety of non-structural element. Now let us go to the problem. Now these are the three basic conditions for which we are checking the sliding. So in case of sliding, if AEQ is nothing but the floor acceleration. If floor acceleration is greater than the mu into g, which is nothing, mu is nothing but the friction coefficient, and if this is meeting, then sliding will happen. And if AEQ is less than g into BH, so B by H is nothing but this is a geometrical property of a non-structural element where B is a width and H is a height. Similarly rocking, it is just opposite to the sliding condition. So if is one of the condition is satisfying, we will tell it as the behavior is rocking. Now similarly third one is toppling. Now toppling, apart from the condition of rocking, we have one more thing. We need to check alpha. Alpha is nothing but it is a ratio of B by H multiplied by G 1/6. Omega is omega is a forcing frequency, and P is equal to root of 3G by 4R. So once these are the basic equation for which we will check the element safety, non-structural safety of an element. Now let us move to the problem. Here we have to assess the safety of an object given in a figure. So here we can see there is a one almirah having the object, rectangular object having B width as a 0.45 meter, height as a 2.1 meter, and length as a 0.9 meter. It is placed at a 4-story building subjected to El Centro ground motion. Now the same element is placed at the different stories. So from ground floor, first floor, second floor, third floor, and fourth floor. So like that it is placed at the 4 different places, and another two values given it as a mu is equal to 0.45 and forcing frequency is 12.57 radians per second. So with this property we have to estimate the safety of an object in both the direction for all the floor. Now this problem was already discussed in class. We will I will show you only the one calculation. So when the object is placed along B, so this is the B side. Now when object is placed like this is a B, this is a H, and we have earthquake ground motion, El Centro ground motion with PGA as a 3.417. We will see what is the condition of sliding, rocking, and toppling in successive session. So now let us start with the sliding. AEQ is 3.147. So for sliding, first condition is if AEQ is greater than mu g. So mu is nothing but the 0.45 multiplied by 9.81. Now AEQ is nothing but the 3.417. So this will give me 4.415. So 3.47 is not greater than 4.415. So this condition is not meeting. So we will write it as a no. Now second, AEQ is less than G into B by H, where G is 9.81 as all of you know, B is a 0.45, H is 2.1, which is coming around 2.102. Again 3.417 is not less than 2.102. This condition is also not satisfying, so we will write it as a no. So together, if any one of the condition is satisfying, we can say that the structure is failing in sliding. So here, since both are no, we will conclude it as a safe. So the current object given in the study is safe against sliding. Now similarly, we will assess the safety for rocking. Now we already have value AEQ should be less than mu g. So earlier it was 3.417, the floor acceleration will be the constant, and we know that we have value of 4.415, which is already calculated for the condition of sliding. So now this condition is meeting, hence we will write it as a yes. Now one can directly tell that if one of the condition is satisfying, we can say that it is unsafe. But let us, for the sake of calculation, let us check the second condition, where AEQ should be greater than G B by H. Now here AEQ is 3.417, which is greater than the value calculated as a 2.102. So this condition is also yes. So together we can say that the structure is unsafe for the condition of rocking. Now let us move for the toppling. Toppling, we have AEQ less than G B by H, so which is already not satisfying. This condition is no. We have value of 3.417, which is less than 2.102. So hence this is no. Now let us go for the second case. Now second case, a little bigger equation, where we have to compare AEQ with product of alpha G multiplied by 1 plus 1 upon 6 omega, which is nothing but the forcing frequency, divided by P. Before we go to this one, let us calculate what is P. P depends upon H, so I will first of all I will calculate R. R is B square plus H square. So here B square is 0.45 square plus 2.1 square, so which will give me value of 2.148. I will use this R for the calculation of P, which is nothing but the root of 3G upon 4R. Now substituting value of R over here, I will get value of P as a 1.85. Now let us put all the values. Before that we need to calculate alpha also. Alpha is nothing but the B upon H, which gives us ratio of B is 0.45, H is 2.1, we will get it as a 0.214. So substituting all the values, we will get it as a product of, we need to compare AEQ with 0.214 multiplied by 9.81 bracket 1 plus 1 by 6 into forcing frequency was given as a 12.57 radians per second and P is 1.85. So when we compare it, it comes around 3.417 is greater than 4.4772. So this condition is not meeting. This is no, this is no. So both together we can say that it is safe against toppling. So this is the result, we got it. Here we can see for first condition it was no, hence it was safe. So here we have safe for sliding, not safe for rocking, and again safe for toppling. Now similarly the same problem here, we will consider one more case where our almirah is placed along the longer dimension. So now we have greater L, it is placed along L. L is nothing but the 0.9 meter, and here we have H. So the case is same. Here all the PGS value for all the floor is given. Earlier we have selected the case for ground floor. Now I will consider case for the fourth floor, which is nothing but the over here. Now PGA is given as 0.4756. So we will check it for sliding. Now for sliding, again we have two equation. First equation, we need to check it as a AEQ, which is the ground acceleration, if it is greater than mu into G. So 4.756 multiplied by 4.415. So this condition is meeting. So we got, for first case itself we got yes, so we can directly say unsafe, but let us go for second as well. AEQ G into B by H, this is 4.756 less than 9.81 into B by H. B by H is nothing but the 0.4285. Now here you just need to consider, though it is in equation it is written as a B by H, B is a side or the dimension along which our element is placed. So here B is 0.9 divided by 2.1, it will give us 0.4285. So the same value we are putting and we will get it as a 4.204. So though this condition is not satisfying, but one of the condition got satisfied. So ultimately we can say that when the almirah is placed again along the L for fourth floor, it is unsafe. It is unsafe for sliding. Now let us move for the rocking behavior. The first case for rocking is just opposite to the sliding, where acceleration is, or it should be lesser than the mu into G. So value was 4.756. Earlier we got it as a yes, so it should be no. This is no. And second case, which we got it as a no, here it is reverse, so we will get it as a yes. V by H value was 4.756. It is greater than 4.204. So this is yes. So as I said, one of the condition is getting satisfied. Ultimately, this element at the fourth level is unsafe for rocking. Now let us move to the last one. Lastly, we have the first condition for toppling is AEQ should be less than G into BH, which was not satisfied. You can directly see from the sliding case. I will move to the B case, where we have to compare AEQ with alpha G 1 plus 1 by 6 omega P. Now this value will be constant. This will, here there is no parameter which can change the B value, hence we can directly go with earlier value of 2.1132. Alpha is the only value which will change, which is 0.4285 and into 9.81. So this will give me 4.756 greater than 8.962. So this condition is also not meeting. So we can say that if both are not meeting, it is safe. So now we can see here it was not safe, not safe and safe. So in summary, we can see that when the structure is placed along the direction of B and we are considering the force or the acceleration direction is parallel to B, here we can see it was safe, not safe or safe, like this. And here one more point we have to consider is, as we go from first floor to the fourth floor, PGA goes on increasing, and The two major factors which decide the safety of any non-structural element for sliding, rocking and toppling is, one is the PGA value, another one is the direction or the side along which it is kept. Now here, for this is a table for when the element is kept along the B direction. Now the same PGA, here for this example we are keeping PGA constant, but in reality the earthquake have different PGA or the different PGA value in two different direction, but for the calculation here we kept as same. So there is no change in PGA for the floor, but by just changing the dimension or the direction of a non-structural element, we can see the safety of element in sliding, rocking and toppling for different floor changes. So the placing of element on the particular floor will decide whether it is failing because of sliding, rocking or toppling. Thank you.